Hi, welcome back. Today's notes are all about using T-charts to graph lines. We have spent 2 weeks learning about slopes and lines. We have learned how to graph lines in several ways. We talked about rise over run, which is graphing the slope using the slope, which is the vertical change of the line, over the run, which is the horizontal change of the line as it moves left to right. We also talked about slope-intercept form. This is a special way that a linear equation can be written that gives us clues about the line. The number that is right in front of the x, which is shown as an m here, is the slope. And the number on the end of the equation, which is shown with a b here, is the y-intercept. And we also talked about a 2-point slope formula. Anytime you are given 2 points, you don't need to graph the line. You can use a formula, which is very similar to this one. It's the change in the y over the change in the x. We said it was point y2 minus y1 over x2 minus x1. Hopefully this is all just a review for you. Now, to continue our review, I'd like you to graph some lines on the coordinate plane below. Use any method that makes the most sense for each line. So you'll look at the ways that you already know how to graph and you'll figure out which one do you want to use. So first, graph the line y equals -1/4 x plus 5. So right away, I can look back up here and I see this y equals mx plus b. This is the exact form that we like to see. I'm going to highlight the numbers that are important here. -1/4, that's the m, or the slope, and +5, that is the y-intercept. So slope and y-intercept. All right, let's go ahead and graph that. Let's find the y-intercept of +5. 2, 3, 4, 5. That will be our first point. Now the slope is -1/4. That's not really rise over run, it's dropping. It's drop over run. The negative means it's going down 1 and over 4. So down 1 and then 1, 2, 3, 4. This is my second point. When you have 2 points, you can make a line. And just remember to put the arrows on the end to show that it is a line. Just to double check, go back up and look at the slope. It's got a negative, and this is a negative or downhill slope. Second, graph the line that goes through point -8, -5 and has a slope of 2. Now, this is very similar to the first one. You're going to be given 1 point, and you have to use the slope to find your second point. X is -8 right here, the same time that y is -5 right here. So here's where they meet. That's our first point. Slope of 2. Anytime you have a slope that says a whole number, remember that you can put any whole number over 1, and that doesn't change. So the slope is rising 2 and running 1. Rise 2, run 1. I could keep going. Rise 2, run 1. Rise 2, run 1. You can do that all day long, and you'll get all of the points on a line. Connect them all together, put your arrows on the end, and you have a line. Third, find the slope of the line that goes through points 4, -10 and 9, 2. All right, you're given 2 points, so you really need to use the 2-point formula to figure out the slope. You could graph it, but for the purposes of this review, we'll use this formula. y2 minus y1 over x2 minus x1. This is going to give me the slope. Now, I like to go back and put my x's and my y's in my coordinates here so I don't get confused. Let's make this point 1 x1 and y1. This will be point 2, x2 and y2. Now go back to your formula. Take your y2, which is this one. Subtract your y1, which is this one. Over, take your x2, which is this one. And subtract your x1, which is this one. It's not as complicated as it seems. 2 minus a negative 10 is the same thing as 2 plus 10, which is 12, over 9 minus 4, 5. And that's the answer. The slope of this line is 12 over 5. Next page. Today we are going to learn yet another way to graph lines. This will be our final way. This is called a t-chart. A t-chart makes use of the y-intercepts, which we already know, but it also makes use of x-intercepts, which we haven't talked much about. The x-intercept is the location where the line crosses the x-axis. I have my x-axis and my y-axis. Most lines will have both an x and a y-intercept, like so. I have a question for you. Can you think of a line that doesn't have both an x and a y-intercept? Describe it. So pause the video for just a second and think about a line that doesn't have both an x and a y-intercept. All right, I was thinking about a vertical line, a line that goes up and down. Let's just make one here. I'll put it right there. Assuming this goes straight up and down forever and never turns towards the y-axis, this one is never going to cross the y-axis, but it does cross the x-axis. Or maybe someone thought about a horizontal line, or a line that goes left to right. Well, let's just put one down here. And again, assuming that this is really straight or parallel to my x-axis, this would never cross the x-axis. It only crosses the y-axis. So those are two examples of lines that don't have both an x and a y-intercept. Now look at the y-intercept above. Let's use the original one here. What value do you think x has at that spot? Well, the y value is going to be some number, like maybe 1, 2, it could be 3. But what value does the x have? Well, on the right side, my x goes positive. Let's just say it's 1, 2, 3. On the left side, it goes negative. Let's say it's negative 1, negative 2, negative 3. Right here, where these two lines cross, it's 0. So the x value is 0. Now look at the x-intercept. Let me highlight the original one right here. What value do you think y has at that spot? Well, it's the same thing here. The x is going to be a number, maybe a negative 1, 2, 3, 4. But the y is going to be a 0. This point here doesn't go up into the positive y values, and it doesn't go down into the negative y values. It stays here at the origin. And this is an important thing to realize. The y-intercept will always look like this, where you have the 0 for the x value and you have some number for the y. And the x-intercept will always look like this, where you have 0 for the y and some number for the x. This will be important as we move along to our next thing today. Let's make sure we understand the intercepts here. Give the coordinates for the x-intercept and the y-intercept of the following line. Well, first of all, I want to find them. This is my x-axis. Where does that line cross it? Right here. This is my y-axis. Where does the line cross it? Right here. So the x-intercept is at point 1 and 0. The y-intercept doesn't go anywhere for x, right? So it's at 0 and -2. Moving right along. We can use our knowledge of the intercepts to help us graph lines. The next step is learning how to use a t-chart to find 2 points. Remember, you only need 2 points to graph a line. This is what a t-chart looks like. And you can see this blue in the middle here, it really resembles a lowercase t. That's why it's called a t-chart. In the left column here, you'll write the values for x. In the y column here, you'll write the values for y. And really, what you are going to be writing are your coordinates, x, comma, y. You'll just put the x number on the left and the y number on the right. Now, since you only need 2 points to graph a line, it makes sense to use the x-intercept and the y-intercept as your 2 points. Why? Because one coordinate will always be 0. That makes the math easy. Anytime you can multiply something by 0, you get 0. And I'm all about making the math easy. Next page. Let's look at a line. Use the line 3x plus y equals 6 for an example. We want to graph the line using the intercepts, both the x and the y-intercepts. Here's the first step. Find the y-intercept. Now remember, on the last page we said that the y-intercept has an x value of 0. Well, substitute a 0 for x in your equation up here. And then you'll find the answer for y. So in place of my x, I'm going to put a 0. 3 times 0 just becomes a 0. Plus y equals 6. Once you've done your substitution, then you just use your math skills to solve for y. And in this case, luckily, it's pretty easy. 0 plus y equals 6. Y equals 6. So when x is 0, what is y? 6. So the point 0, 6 would be the y-intercept and one of the points on line 3x plus y equals 6. Show point 0, 6 in the t-chart below. Put 0 in the x column and 6 in the y column. 0 was x and 6 was y. Now these values that we just put in represent points, represent the coordinate pairs that will be placed on the graph. You could, some people even put a third column, or you could just put it off to the side. Just make sure that you realize that you're talking about the coordinates. We can actually find that coordinate. Let's find the point 0, 0, 6. When x is 0, y is 6. Now let's move on to point 2. Find the x-intercept. This time, make the y equal to 0. So what is x when y is 0? Let's go ahead and bring our formula down. It was 3x plus y equals 6. Now I'm saying substitute a 0 for the y right here. And the 3x stays the same and the 6 stays the same. Now let's use our math skills to figure this out. 3x plus 0, I can ignore, equals 6. This is a one-step algebra problem. Divide both sides by 3. You can cancel out. 3 over 3 becomes 1x. So x equals 2. I just found my second point. Point 2, 0. Let's go ahead and graph that. When x is 2, y doesn't go anywhere. Y is 0. You only need 2 points to graph a line. Put arrows on the end. Next page. Let's do a new example together so you can see the process from start to finish. This time I'm going to use my finger to cover up a variable every time it's 0. This might help you do these problems even quicker. This is the line we want to graph this time. X plus 2y equals 4. I want you to remember that we're going to find the x and the y-intercepts. So looking at a t-chart here, I'm going to have x as 0 for x for my first point, and then 0 for y for my second point. Let's do the first point. Substitute a 0 for the x in your equation. Well, if x is 0, this variable just goes away. I'm going to cover it up. And what am I left with? 2y equals 4. That's an easy problem to solve in your head, but you could also do it out to the side. 2y equals 4. Let's divide through both sides by 2. 2 over 2 becomes 1 and cancels out. Y equals 2. Good. Now you put the 2 here, and you have your first point, point 0, comma 2. Now the next step, we have to substitute a 0 for our y up above. If I put a 0 here for my y, I have 2 times 0. And what is that? 0. So this entire variable is gone. I can ignore that. What is x? Look, no math is needed whatsoever. X equals 4. This is my second point, point 4, comma 0. And the last step here is basically putting your 2 points, point 0, comma 2, and point 4, comma 0, on your coordinate plane. And here's point 0, comma 2. Here's point 4, comma 0. Draw a line to connect the dots. I hope it helps you to have a graphic representation here of how to do that easily with just your finger to cover up the numbers. Now let's practice on our own. Use the intercepts to graph the line x plus y equals 3. So when you're doing this, I'd like you to find 2 points. One of them will be the y-intercept, one of them will be the x-intercept. Go ahead and substitute 0 for your x up here, covering it up, and then figuring out what y would be. Go ahead and do these 2 on this page, and pause the video to do it on your own. Okay, let's get back together again now. Hope that wasn't too hard for you. Let's do it together and see how you did. So first I want to substitute a 0 for my x. If x becomes 0, this variable is gone, and y equals 3. I didn't even need to use any math, did I? That's my first point, 0, comma 3. And I'll go ahead and just find it now. You can find it as you go or at the very end. When x is 0, y is 3. For the next point, the x-intercept, I want to substitute a 0 for the y. Same thing. If this is 0, I don't need to even think about it. There, can you see that okay? X equals 3. Put a 3 in over there. My second point then is 3, comma 0. When x is 3, y is 0. Connect your dots with a ruler. All right, hopefully you got that one correct. Let's move to the next one. Use the intercepts to graph the line 4x plus y equals 8. This is slightly harder. Same theory though. Use your intercepts to make it easy because you get to use a 0. For the first point, if I substitute a 0 for my x here, I have 4 times 0 is 0. I can still just get rid of that. What's my y? Y equals 8. So here's a point, 0, comma 8. When x is 0, y is 8. That's my y-intercept. To find my x-intercept, I'm going to use the 0 to substitute here for the y. So that's gone. Cover that up. Now I have 4x equals 8. I'm not quite done. 4x equals 8. This is a one-step algebra problem. Divide through both sides by 4. X equals 2. So my second point then is 2, 0. When x is 2, y is 0. There we go. Use a ruler, connect the dots, draw your line, arrows on the end, and you're done. And incidentally, one thing to note is that oftentimes when people are drawing a line and they know the equation for it, they'll just write the equation next to it. This is the line for x plus y equals 8. I won't be very picky about that, but I did just want to let you know. Okay, next page. Use the intercepts to graph the line negative 3x plus 4y equals 12. So same thing. We're going to use a 0 for our x here. Negative 3 times 0 is 0. And I have 4y equals 12. You could probably do it in your head, but let's go ahead and do a one-step algebra problem. Divide both sides by 4. 4 over 4 becomes 1, and those can cancel. Now I have y equals 3. So when x is 0, y is 3. Let's go ahead and put 0, 3 as our first point. There we go. For your next step, you're going to substitute 0 for the y. 4 times 0 is 0, and that's gone. Now I have negative 3x equals 12. Same thing, one-step algebra problem. Divide both sides by negative 3. You want to leave only x on the left. And just don't forget to bring the negative over with it. Negative 3 over negative 3 becomes 1, and that cancels. X equals 12 divided by 3 is 4, and you have a negative there on the side. X is negative 4. So my second point is negative 4, 0. X is negative 4, and y is 0. That wasn't too hard. Just took a one-step algebra problem to solve each of those. And draw a line with arrows to show it's a line. Now this line that represents the line negative 3x plus 4y equals 12, this line here represents all of the possible solutions. I just showed 2, but obviously this point is on the line, this point is on the line, this point is on the line, this point is on the line. That's what a line is. It's an infinite number of points that goes on forever. All right, so far so good. I do want to do a short extension here. So far we've only talked about finding 2 points, the x and the y-intercepts. However, we know that a line is made up of multiple points. You can use your t-chart to find as many points as you need to on a line. Now here we were just using zeros for one of our coordinates. And you can put any number in there. I usually choose zeros or numbers close to 0, like 1 or 2 or negative 1, just because it makes the math so much easier. Let's use the example above and just extend it. Let's add 2 more points to the t-chart. I can even continue drawing it down here. Let's add, let's see, what happens if we add a 2? If x is 2, what is y? Plug it into our equation here. Negative 3x plus 4y equals 12. So if x is 2, we have negative 3 times 2 is negative 6 plus 4y equals 12. To get rid of this negative 6 here, I have to add 6 to each side. Now I have 4y equals 12 plus 6. That's 18. Divide through both sides by 4. 4 over 4 becomes 1. I can ignore that now. Y equals 18 over 4. I think that's 4.5 or 4.5. Good, I'm glad it didn't turn out as a whole number, because you should know that you can have values in your coordinates here that are fractions or decimals. So one of our points is 2, 4.5. When x is 2, y is 4.5, which will be right here. Let's see if we got it. Ah, we were pretty much right on. That's point 2, 4.5. So I'm going to let you go ahead and pick a fourth point on your own, but I just wanted you to see that you don't always have to choose the x and the y-intercepts. Makes your math easier, but you can choose any number. If I wanted to, I could say, do something off of my coordinate plane. I could put in a -20 and see what my y value would be. All right, very good. If this is still a little bit confusing, I hope you'll rewind and watch the lecture again. Thank you.